You scroll every day. But do you know why it's not smooth? Spoiler, it's supposed to be jagged. Your trackpad is lying to you. It smooths reality with software interpolation, tricking your brain into thinking friction is optional. But friction is the entire point. Let's dismantle the gesture-based UX illusion, starting with what actually lives inside a mouse. Modern laptops use capacitive arrays that read your finger's electrical field. The operating system then runs a smoothing algorithm, predicting where you mean to go instead of where you actually are. This solves latency but introduces a new bottleneck, spatial drift. You think you're at the top of the document. The software thinks you're still scrolling. That's not navigation. That's guesswork. Back in 1995, mice used potentiometers, a simple resistive strip that changed voltage as you turn the shaft. It was elegant, analog, and predictable. But resistive surfaces wear down, dust builds up. The voltage signal gets noisy. Engineers needed a way to keep counting rotations without physical contact. Enter the optical encoder. Optical encoders use a slotted disc spinning between an infrared LED and a phototransistor. Light gets chopped into pulses. Each pulse is a discrete digital click. Nowhere, no signal drift. But here's the catch. Light doesn't tell your brain you're moving. It's silent. Engineers had to solve the tactile feedback problem, which led to one of the most brilliant mechanical compromises in human history. They added a ratchet mechanism, a spring-loaded detent wheel that physically resists motion at precise intervals. That click you feel, it's structural stress being converted into spatial mapping. Your fingers don't need smoothness. They need boundaries. The ratchet gives you a haptic coordinate system, turning abstract scrolling into physical navigation. It's engineering poetry. Touchpads try to replicate this with finger swipes, but fingers lack the mechanical advantage of a thumb on a spring. Your palm rests flat, your wrist rotates, and suddenly a two-finger scroll becomes a gesture recognition puzzle. The OS has to guess if you meant to scroll, zoom, or open a menu. It's overcomplicated. You're not training your hands, you're training your patience, and that's where the real bottleneck hides. Latency. Gesture processing requires CPU cycles. The OS captures touch data, runs it through a neural filter, applies easing curves, and finally moves the cursor. By the time your screen reacts, your brain has already predicted the outcome and corrected itself. The scroll wheel bypasses this entirely. Hardware certainty beats software prediction every time. Thin laptops demand thin trackpads. That means cramped flex cables, zero thermal relief, and capacitive layers stacked directly over the palm rest. Under heavy use, heat builds up. The OS compensates by throttling gesture sensitivity, causing stuttering inputs. Meanwhile, a mechanical scroll wheel sits in a ventilated mouse, dissipating structural stress without breaking a sweat. Physics doesn't care about your chassis design. Look at a 1988 mouse. The scroll wheel wasn't a feature. It was a necessity for power users. Designers didn't optimize for aesthetics. They optimized for throughput. Every detent was calibrated to match standard text line height. You weren't just scrolling. You were counting. You were navigating with precision. We traded engineering rigor for glass slab minimalism. If you argue that touchpads are better for portability, you're conflating convenience with competence. Carrying a mouse is a skill issue. But don't confuse carrying weight with lacking control. When you need to edit code, scrub through video timelines, or navigate 2,400 lines of spreadsheet data, you don't want guesswork. You want the ratchet. You want the click. You want the truth. The scroll wheel wins because it respects human biomechanics. Your thumb joint naturally rotates in arcs. The wheel follows that arc. The detent matches your muscle memory. Touchpads force your fingers into flat, friction-heavy planes. It's biomechanically inefficient. Engineering isn't about making things pretty. It's about making things work, and working means feeling every single step. So drop the two-finger swipe. Reconnect your mouse. Feel the detent. Let the ratchet do the heavy lifting. If you're still scrolling smooth, you're not missing out. You're just accepting bad design. Comment below if you think trackpads can ever replace the wheel. I'll be here, waiting for your argument to hit a spatial drift bottleneck. Keep it jagged.